How do we truly measure in AI? And who decides what better really means? Well, in today's episode, we're going to explore the often overlooked yet foundational topic of AI performance benchmarking. And I've got the perfect guest for that. His name's David Kanter, founder of MLCommons and steward of the MLPerf benchmarks. And while AI headlines typically focus on jaw-dropping capabilities or controversial use cases, there is an entire ecosystem of unsung heroes, consisting of engineers, academics, and industry players who are all collectively quietly working to define how progress in AI is not only progressed, but measured, and why it matters to enterprises, regulators, and everyday users alike. So we're going to take a peek behind the curtain, take a look under the hood, as David shares how what began as a volunteer-led gathering of experts at Stanford evolved into MLCommons, a non-profit committed to building open, fair, and representative benchmarks that capture the full-stack performance of AI systems, from silicon to software. And in a world where AI performance is accelerating at a rate that far outpaces Moore's law, up to 50 times faster by some estimates, he explains why standardized open source benchmarking is vital for transparency, accountability, and progress. So our conversation will cover a wide range of topics on how MLPerf extends beyond data centers and into consumer devices and automotive applications, the role of efficiency as both a limiting factor and innovation driver, and why some of the largest players from Amazon or IBM have yet to participate publicly. So whether you are an enterprise buyer navigating AI procurement, a hardware vendor racing to optimize efficiency, or simply someone curious about how performance metrics shape the future of intelligent systems, this episode offers a grounded and nuanced perspective. So, enough from me. Time to get our guest onto the podcast now. So thank you for joining me on the podcast. Can you tell everyone listening a little about who you are and what you do?
Absolutely. And first of all, thanks for having me on, and thank you to everyone in the audience for tuning in. So I'm David Kanter. I'm the founder of MLCommons, and I'm on the board and lead the MLPerf benchmarks. And those are the industry standard benchmarks for measuring the performance and energy efficiency of AI training and inference. And so it's actually in a lot of ways a dream job for me. For a long time, I was an industry analyst, much like yourself, and I always worked a lot with silicon folks, focusing on sort of how do we deliver the next generation of high performance systems, whether it's, silicon technology, packaging, computer architecture, networking, all of those things. And, I got to be where I am in a kind of unusual way. And when MLPerf started out, it was and still really is a community collaboration. And so there was a call on the internet to say, hey, if you're interested in solving this problem, show up at this meeting at Stanford. And I showed up, and a lot of my friends were there. This is, many of the architects who work on AI chips are folks who I've known for, 5-10 years. And one of them, my friend Kim Hazelwood, we're going along in the meeting, we're talking, thinking about solutions, fast and furious. Everyone's, great spirit, like, what are we going to do? And, I raise my hand and I say, hey, should we be writing this all down? Right? Because, there's people who couldn't make the meeting. Let's write it down so we can distribute notes out to them. And, my friend Kim Hazelwood, she's at the time was an engineering manager at Facebook AI research at FAIR. She's like, you're our scribe now, right? You identify the problem, you get cursed with solving it. And so, my joke is I started out as the secretary of the group, kind of like Mad Men. But then eventually I graduated to being secretary of the group like Ban Ki-moon. And so when, after we had actually established the first two benchmarks, we knew we were going to make a nonprofit to get it started. And, I'd been doing my own analyst thing, been running my own consulting business. I knew a lot of the folks. I said, David, would you like to build it and run it? I said, yeah, that sounds great. And so that's how I became the, person number one at MLCommons. And, it's been awesome to see it grow, now to 20 or so people. And we've got, a lot more than MLPerf. We have data sets, we have AI risk and responsibility, and many things going on all around the theme of how do we make AI better for everyone, which is really the mission of the organization.
What a fantastic story. And in 3,500 interviews on here, one of the things that keeps reoccurring is how the universe almost pushes us into the right meeting room at the right time. And there seems to be a lot of serendipity in every success story, and something you experienced too, right?
I think there's a lot of things that, contributed to that.
Yeah.
I've been, as an analyst, interacting with NVIDIA and Intel and AMD for a long time. And even some of the startups, I had been consulting for them in various capacities, sometimes working on patent-related matters, sometimes working on other stuff. And so I knew a lot of them. I'd seen some of their talks at Hot Chips and other conferences, and everyone was really, really pretty comfortable with me. And, also it was to the credit of some of the folks involved, taking a bit of a gamble, right? You had someone who was an analyst in the room, and, and this is one of those things where I think it's always open. It's good to be open-minded to folks and, kind of let the talent reveal itself. You never know who's going to prove to have just that right set of skills that you need to bring everything together. And part of it is, a lot of folks could talk to me and trusted me. And part of the role of MLCommons is actually that trust, that everyone trusts us because we're going to do the right thing, and neutrality, right? And those are sort of the key things and ingredients for success in everything we do, which is how do we bring people together to build benchmarks, to focus on AI, to measure things in a neutral way where everyone's going to be happy with the outcome.
And I would say, yes, go on.
And serendipity has definitely been a big part of it, not just in, me showing up to that first meeting and catching the eye of various folks who are involved, but many of the people who we've interacted with, or members who have joined, if it wasn't for, I sat next to that person at a conference, it wouldn't have happened. There's so much luck in every success. It's, skill and hard work too, but luck always plays a huge role.
Yeah, I would say all three of those are so important, especially when they converge. And fast forward to 2025, we're hearing a lot about AI performance improvements, also a refreshing focus on ROI and making measurable differences. So how do you at MLPerf benchmarks translate these real-world benefits for enterprises, startups, and even everyday consumers? Because there's a big focus on this now, and quite rightly so.
Yeah, absolutely. So, as I said, we come together, bringing everyone in the industry. We've got, and academia too, right? I should be clear that MLPerf, really started from both academic and industrial roots. And there were a lot of benchmarks that had come before us for AI. I think 2 or 3 that had been tried, and they never really got critical mass. And I think part of it was that when we came together, we kind of looked at all the prior efforts, and we said, okay, first of all, we're all interested in this, so let's combine our powers, but also let's learn from the lessons we had before. And I think one of the key principles that we have is we want our benchmarks to be fair and useful and generalizable. And that is, they need to be representative of what we're doing in the industry. And because it's a lot of work to do a benchmark. If you're one of our partners, our members, spend a lot of time, a lot of money, a lot of engineering on getting the benchmarks built, getting them ready, getting them optimized. And that effort can't be wasted, right? We can't just be doing it as a stunt. It needs to be something that actually benefits the whole community downstream. And so that's been a, sort of first principle for MLPerf from day one. And so a lot of that is selecting the right workloads, making sure that they're really representative of people's real work, talking to customers and making sure we know about what they want and getting some of their feedback. And that can mean some of the leading AI labs, and of course, some of the hyperscalers we're blessed to have as members, and they can help guide us. But increasingly, talking to some of those customers and hearing from, we're doing an RFP. I talked to a government lab a little bit earlier, and they said, we're doing an RFP using these 3 of your benchmarks. Not all of them are relevant, but, for the problems that we have, these 3 are the ones we really care about. And so, the goal is, as with any benchmark, it's not perfect, right? The best benchmark is you take your workload and you run it. And, the biggest companies in the world can do that, right? They'll have teams of engineers that do that. But, our goal is that many of our benchmarks should be representative of what you're doing so that, people keep on telling me LLMs are pretty popular, right? Mm-hmm. So we've got an LLM benchmark, got actually several. So, one we have is fine-tuning Llama 2 70 billion with LoRa. And now that benchmark, we've chosen a set of parameters, we've chosen a data set. It may not be exactly what you're doing in production, but it's really close. And so, it'll tell you, directionally who's better, right? So if you've got one solution that's 2x faster on Llama 2 fine-tuning than the other, there's a pretty good bet that for you, that's going to translate. Now, it may not give you the exact, you got 10 queries per second here, and yeah, you're going to see that in production. It's going to depend on your system, which might be a little bit different, and it's going to depend on your data. And, if you're building a customer service chatbot, I can't predict all the queries you're going to get, and you probably can't either, but it'll really point you in the right direction. And that's the goal of benchmarks. It's not just how do we bring together buyers and sellers, but it's also how do we point the whole industry at ideally true north. But, with any benchmark, it's if you can get within 5 degrees of north, you're doing pretty well. And the whole point is we go there together, and that moves the industry much faster. And so we see a lot more progress. One of my favorite talking points is when I look at the speed of AI training from when we started, we've seen that we're consistently doing better than Moore's Law, in part because we use software, we use algorithms, there's so many tools we have, but we're looking at something like 50x improvements in performance, which is just incredible over, something like a 5-6 year time frame.
Wow, that is just incredible, especially where we're both from a time where the speed of tech progress was almost determined by Moore's Law, and that's right. Observation that the number of transistors in an integrated circuit doubles every 2 years. So MLPerf data, it's just blown that out the water completely, and anyone experiencing the speed of change right now will testify to that too. So what's fueling this unprecedented growth? And how do you see any limits to this acceleration? Because it seems almost limitless right now. But how do you see this playing out?
Yeah, well, so I think getting back to it, there's a couple of podcasts I listen to, and some of them have made a really great point, which is when you think about AI, it's like, how do we add more intelligence in the world, right? Whether that's to the feed that shows what news and what ads to give to me, or, I'm in San Francisco, so I actually really enjoy taking Waymo. It's a wonderful ride. It's super safe. And, so when I think about things like how many people die on the roads due to errors, right, it's clear to me that in the not terribly distant future, we're going to see that AI is actually safer and more efficient than humans in many cases. Right. And I would, I'd love to think I'm a good driver, but I get distracted. right? And that's the great thing about some of these AIs, right? They never sleep, they never rest, they don't get distracted, they don't have a bad day at work and get cranky. And so there's just so much possibility for what we can do with putting this intelligence everywhere in the world that, we see people really take in this approach of let's attack the problem from every angle. And I think that's actually one of the key insights at MLPerf is it's not just a hardware benchmark. It's about software and hardware and the full system. And so, I like to say it's everything from that transistor, right? That, the researchers at Intel, at TSMC, at Samsung, Micron, all of SK Hynix, all of these companies are working on making better, to software algorithms, to frameworks, right? If you look at these to neural network architectures, right? How do we make them more scalable, right? Because one of the things we've seen is, like, obviously our hardware gets faster, we get more transistors, we get more advanced architectures, but also we're seeing people find ways to use even more chips and bigger systems for training. And that's actually a pretty non-trivial aspect of what goes on, right? Which is, it used to be you just trained on smaller systems. And as we get the capability to do bigger and bigger things, we can do, more data, which ultimately drives sort of more intelligence and more capabilities. So there's just, and if you look in the research side, people are starting to look at all sorts of optimizations in how we build systems for AI to give us that extra performance, to be more efficient. And, it's kind of no stone left unturned, which is really exciting to get to see those benefits. And some of it is also the rapid change, right? Like any field when you're in its infancy, like the changes are tremendous.
And something we must talk about as well is how AI, yes, is incredibly powerful, but is also incredibly power hungry. And there's a lot of debates around sustainability, and especially when many people have filled our LinkedIn feeds creating action figures of themselves. And there's a lot of responsibilities around how you use that technology. So how do you at MLCommons help companies balance performance with energy efficiency? And do you think AI's energy demands could become unsustainable? Or are we going to find new or explore new methods? I know there's a lot of talk of nuclear, for example, or smaller plants there, but how do you see that playing out too?
Yeah, no, I mean, great question. So, and, by the way, one of the first projects that I kicked off actually was doing MLPerf power, which is how do we measure the power and energy efficiency, especially for inference, but training as well. And, my goal is to have power measurement for everything we do as an option. It's a bit harder to do the power measurement, but getting that apples to apples really helps create a playing field where people can compete there. Now, I think you pointed out that the explosive growth of AI is absolutely, something that's, potentially concerning. But, I think the power efficiency in some ways has improved just as much as the performance, right? And what we start seeing is, folks are really, really optimizing for that efficiency because power is sort of the ultimate limiter in a lot of ways, right? So when we start seeing things like reduced precision, so, when we started out doing MLPerf, a lot of people would train or do inference in 32-bit floating point data. And, now we're seeing people training in 16-bit or 8-bit. We're seeing people doing inference in, again, 16, 8-bit, sometimes even 4-bit. And so that helps, that's sort of a technological leap that makes things a lot more efficient. But, I think this is also somewhat of a generational change, right? A lot of people have compared this to the build out of railroads or electrification, where, you're making, or the telecom boom in the 90s, where you're just making these massive investments. And I think part of what's challenging is that we need new data centers, right? So one of the things that's very interesting is a lot of AI chips are increasingly energy efficient, but they're also high power, right? I remember, and you probably remember a time when, maybe 10 years ago, people would say, hey, you can't cool a chip that's more than 120 watts, right?
Yeah.
It's impossible. Well, the job of engineers and scientists is to take something that's impossible and make it ordinary in a few years, right? And so now we're seeing people air cooling chips that are 500 or 600 or even a kilowatt. And one of the things that's cool is that lets us get more performance into a smaller unit area. So that system, even though on the face of it, it's like, oh gosh, that went up from 200 to a kilowatt, it's actually a lot more efficient in many regards. But now the challenge is, some of those older data centers that we had, an 8 kilowatt rack, like that was pretty normal in the 90s. That may not even hold a single server, soon. And, is that a problem with the data center? No, I mean, we built for what we could do at the time, but it's just the thing that's really efficient is different. And so, it is exciting to see people start thinking about, exotic cooling options and all sorts of things that we can bring in to make things more efficient. But I mean, to your point about, let's think about co-locating power plants, that's the industry responding to sort of this once in a generation kind of change with really creative out of the box solutions.
And before you came on the podcast today, when I was doing a little research on what we could talk about together, one of the things that immediately stood out to me was that major players like Amazon and IBM, for example, are not actually submitting their MLPerf results. So why do you think that is? And should AI buyers and enterprises, should they be skeptical of vendors who don't participate?
Yeah. So, the first thing is, we're a very friendly community. We're global, we're inclusive, we want everyone to feel at home, but we also understand that, it's voluntary, it's an opt-in kind of thing. Now, as a buyer, absolutely. One of the things I like to tell folks is when we looked at how benchmarks worked when MLPerf started, it was almost as if you would go out and buy a car and you'd have 3 people there, and one would say, oh, my car can go from 0 to 100 kilometers an hour in 2 seconds. Next guy says, my car can go 300 kilometers an hour on the Autobahn. And the third guy says, I have seat belts. You're like, wait, these are all different, right? And so the part of the value that MLPerf really brings to the table is it aligns everyone on what it means to be better and sets apples to apples standards so you can actually make that decision. Now, as to why folks don't participate, I cannot, I can't really tell you why, but I would say that you would have to, of course, speak to the folks like Amazon, like IBM, like Apple. All of our code is open source. So I can tell you many of those folks internally run our benchmarks for sure, but they may not want to participate publicly for whatever reason. But, as a buyer, right, I think these tools are meant to help with RFPs, to help people understand what they're buying, to make sure that they're getting the right thing. I talked a few years ago, there was actually a fairly large company, very, very talented IT folks, and they had gone out and bought a cluster with hundreds or thousands of accelerators, and they could only get 30% utilization out of it, because their storage system wasn't configured correctly. They hadn't thought about that. So, of course, they got a new storage system. And that was actually one of the motivators for us starting to do MLPerf storage. So we're like, okay, if these guys made a mistake, then, our job is to shine a light on it and help folks get the right system and make sure that it's configured so that at the end of the day, when your vendor gives you the keys, that everything's hooked up correctly. And so I think, MLPerf can be used both to compare the systems before you buy, but also, to say, hey, and I've seen this with several supercomputer RFPs where they say, okay, we want this kind of performance on MLPerf, and as part of the acceptance criteria, you've got to reproduce it. You got to get within 5% or 10% of whatever you bid. And that's, really important because it means that you aren't going to be left, if you're an enterprise buyer, right, you want a solution. You don't want a box of Legos with instructions on how to build it together, right?
Yeah, 100% with you. And you mentioned there that some of these major tech companies found their AI clusters running at just 30% utilization because of storage limitations. And I think the point you highlighted there is one of the big under-discussed AI challenges, the role of storage and data pipelines in performance. So how are you at MLPerf Storage helping to solve that problem too?
I think a lot of this is, again, it's such a new field. We're always finding new knobs, new challenges. And so I think that really was the motivation for MLPerf storage. Is it's a full system problem. And when we built MLPerf training and inference, those focus on the compute aspect. So there's a little bit of storage in there, but it was largely designed so that those benchmarks could run without a huge storage footprint. And conversely, then we took a look and we said, okay, gosh, we know there's a storage problem here. And all the storage vendors, we brought them together and said, well, we want to make sure that our systems are ready for the latest in AI training. And when we started, I mean, again, this is also a sign of the time. There's a beautiful story in here. When we started, it was like, okay, AI training is the big thing. That's all we really need to worry about. Inference doesn't have a big storage footprint. And so that's what we focused on. And we came together and said, okay, how do we make sure that these storage systems are configured, capable of sustaining the level of compute we want, but without needing accelerators in the configuration, right? You don't want to go out and buy a 4,000 accelerator cluster just to check out that your storage system works. So we had to come up with something where all the storage folks could do their benchmarking, do their performance analysis, do their optimization without having accelerators. That was one of the key things, as well as bringing in our trust, neutrality, open, collaborative nature. One of the things that I've been very pleased about is all of our working groups are very, very collaborative, even if they're a bunch of competitors, to great esprit de corps. Now, of course, the funny thing is that the rules of the game keep on changing. As I said, when we started MLPerf storage, inference wasn't really a storage footprint kind of thing. But now with reasoning models, all of a sudden, and like before that, vector databases actually do have a significant storage component. And we're starting to see, as the industry looks for how we improve the intelligence of AI in different ways, that's having ripple effects all throughout the ecosystem, which is both exciting and, guarantees that many of us will have jobs for years to come, right? Lots of fun problems to tackle.
And not only that, you guys have also recently launched MLPerf Client, which allows people to benchmark AI performance on consumer hardware. Feels like an incredibly exciting move too, especially now it's going to get more important. But what's the goal here, and how do you see AI benchmarking evolving beyond data centers?
Yeah, absolutely. So, we've that's one of our newest benchmarks, MLPerf Client. Actually, sort of end of April, we had an update on version 0.6 where we added support for NPUs. And just backing up a little bit, yeah. MLPerf Client is focused on how do we measure performance for, sort of PC, desktop, notebook class systems, right? And there it's actually an easier problem than the data center, right? There is no standard operating system, standard platform in the data center. Everyone's data center looks different. Even if you have everyone using Linux, operating systems are actually pretty different. Whereas, on the client space, the platform's a bit simpler. You've got just a couple of operating systems you care about, and they actually have pretty standard flows. And so, we've seen this big push with AI PCs, with intelligence in our client systems, people wanting to run LLMs or image generators locally. Said, okay, got it. We need to be there. We need to be helping to bring our light, our trust, our neutrality into that ecosystem. And so, one of the trends that we're seeing is, obviously many people have graphics cards. You can run some of these workloads on CPU. Sometimes they're split across them. But one of the newer things that we're seeing on both mobile phones, tablets, all sorts of the client chips is people are starting to put in this NPU hardware. And so that was one of the more exciting things, is getting the ability to measure all across everything on these chips for some of the latest and greatest workloads. In our case, we started with a large language model in MLPerf client. And, I've got my eye on a number of other things. I think like doing video generation could be really cool. That's one of those sort of like really emerging areas that, we're starting to see some promise there. But, certainly I would love the ability to generate, a video of myself. Like that would be pretty cool.
Yeah, oh, I love it. And if we dare to look a little further ahead, what do you think are the biggest AI benchmarking challenges that you will be tackling next? And where do you see AI performance measurement evolving in, dare I say, the next 5 years, which in the current speed of things, so much could be possible, especially when nearly everyone will be walking around with AI smartphones, laptops, tablets, etc. It's almost impossible to look that far ahead, but what are you going to be working on next, and how do you see this evolving further?
Yeah, so that's a great question. And to your point, right, this intelligence, we want it everywhere. And so that's sort of the first thing. If I look at the first 5 years of MLPerf, and we started with training, and now we've got performance and power measurement for everything from the smallest tiny devices at the edge, biggest supercomputers in the data center. Right. And so it's filling that out, making sure that we've got it. And I'd say actually keeping up to date with the velocity of the industry. That's challenge number one. Right. And, reasoning models are pretty recent. Talk about 5 years. That's like something that's new in the last 5 months.
Yeah.
And, we got to stay up to date with that. But we have to do it in a way that is industry standard, that's fair, that's open and generalizable. And that's a lot of work. That means we need to build and get new data sets. There's a lot of the challenges we have around building these benchmarks. How do we get the data to measure it? Because some of the most interesting things, there's no open data. But then, I'm increasingly, and this is maybe to the point about data, we're starting to see some real interest in specific verticals. So, one of the projects that I'm very excited about is going to come to fruition soon is MLPerf Automotive. And so, some folks from the automotive industry said, well, look, as we're making more intelligent, more autonomous vehicles, right, we need AI performance in our cars. We need a fair, level playing field to measure that. And so some of the folks in the auto industry came to us and said, hey, can you take the magic of MLPerf inference, but do that for automotive? But, for real automotive workloads, like we want to see the kinds of things that we have in cars. So, don't show me a 1K by 1K image for object detection, right? Cars of the future are going to have 8K cameras all over the place. So it should be 8K resolution, things like that. And so I think as we see, I think that's one direction that we'll see things going, as well as just, a lot of the workloads changing. Like I said, 6 months ago, I think people looked at MLPerf storage and said, or storage in general, and said, that's a training thing, not an inference thing. Well, now it's an inference thing. Networking is another area that I'm keenly interested in and is super important, especially, on the training side. Of course, these big clusters need a lot of networking, but who's to say that networking, we've seen inference start to touch many things that it didn't originally as we've built bigger and bigger models. Maybe we're going to see inference being a role in networking. Or, also, as things have started out, when we did MLPerf, there was really nothing. There was no infrastructure. There were no standards. We're building it as we fly, so to speak. And, now we're starting to see some both de facto and actual standards emerge. So, one of the things that's really exciting is, I think most folks tend to use an API for serving large language models. And so one of the things we started thinking about is, okay, if there's a standard API that everyone agrees on, maybe we should be using that, and we can use that to simplify our performance measurement, make it easier to run, and allow us to compare a wider swath of systems, right? I'd claim that AI is actually one of the first really, really new workloads that emerge after the era of the cloud, right? Databases have been with us forever. Of course, you got cloud databases, but AI was really, at least the modern incarnation, was born after the advent of the cloud. And so, should we be thinking about a cloud native way to measure performance? There's all sorts of challenges out there. And plus, folks like yourself and our listeners going to keep us honest, help us pick the right workloads, and help us make MLPerf ever more useful to the enterprise. If anyone has any ideas on how to make it a better tool for enterprises, please let me know. Like, we want to bring along the whole industry, the whole ecosystem with us, because ultimately, we're a nonprofit. That's our goal. How do we make AI better for everyone? And, we do that together in partnership with everyone.
And I think that is a powerful moment to end on. And for everybody listening that want to make a difference, want to work with you or talk with you, share ideas, where would be the best place to start? Where can they find more information and ultimately contact you or your team?
Absolutely. So MLCommons.org is our website. We are MLCommons on Twitter, LinkedIn, Blue Sky. I am the Kanter on all of those things. And, we'd love to hear from you. So please don't be a stranger, and again, this is part of it, paying it forward for me. I'm just some guy who got lucky and showed up to the first meeting and ended up as the secretary. You show up, you email me, who knows where it's going to go.
And that is what I love about your story, because we're talking a lot around complex technologies, the impact it's going to have on our world. But as we come full circle from that guy that walked into that meeting room all those years ago, it's the very foundations of everything that you do. It's built on a philosophy of open collaboration to improve AI systems. As you said a few moments ago, build a better AI for everyone. So I do urge everyone listening, if they're interested, if they want to make a difference, maybe reach out, share those ideas, see where it leads. And maybe I'll be talking to you too on this podcast in a few years. But more than anything, just thank you for bringing this topic to life today. Really appreciate your time and sharing your story behind the great work you're doing. Thank you.
Thank you. And, thank you to you for having us on, and thanks to the audience for tuning in. Yeah, this has been a real pleasure.
And as we wrap up today's conversation, I think it's clear that benchmarking isn't just about numbers on a spreadsheet. It's about trust, transparency, setting a shared direction in an industry moving at breakneck speed. And as David reminded us, real progress in AI isn't just measured in flops or frames per second, but also in how we collaborate, openly innovate, and how wisely we manage the resources powering this next generation of technology. So maybe David said something today that resonated with you. Maybe it sparked an idea about your own AI systems, or just got you thinking about energy efficiency, responsible innovation. Whatever it is, I want to hear from you. Are standardized benchmarks shaping the right kind of competition in AI? Should more companies be compelled to take part? And how are you seeing AI measurement evolving in your world? So much to talk about there, so please email me, techblogwriter@outlook.com, LinkedIn, X, Instagram, just @NeilC.Hughes. So thank you for listening today. Until next time, stay curious, keep asking questions, and let's try to keep making tech make sense. Speak to you all soon. Bye for now.